Hello, today we will be learning about formal proof format, the way you show your work that shows that you're proving something, in this case, that two triangles are congruent. And then we're also going to go over like what are the specific geometric reasons. And again, remember, it's not just because the two triangles look like they're the same size, but because there's geometric principles we can use to prove it. Okay, so there's two types of, I don't know why anyway, please go to page 12. And when you get there, there should be a blank page. Okay, so I'm going to show you what's called a two-column proof. Okay, that's what we'll use in this class here. Let me see if I can find it on the other one. There we go. Okay, so on page 12, where you got some room under two-column proof, I want you to please go ahead and make these notes here. I'll read it off so that if it's hard to read, my handwriting isn't always so good. But basically what you have is these two columns, right? One says statement, one says reason. And then off to the side, you'll have something that gives you information that that you'll use to make proofs. Either it's directly given, direct, which is given, or it's deduced, indirect. You don't necessarily, I guess, have to take notes on this, but I want you to please understand like what a two-column proof is. It's just a format for entering information that shows what you're concluding, statement. Right. For example, let me give you a real simple example. Fred, let's say I'm making a statement. I say, Fred's a nice guy. Somebody says, well, why do you say that? That's the reason. They want a reason. Well, because he always buys me lunch. Uh, and that would be a reason. Again, that's a everyday one, but we're going to use it for geometry, right? So the statement is either the given information or what can be deduced and the reason for it. Again, if it's given directly, we say the reason is given. If it's something you can figure out based upon the information you have, what can be deduced, a fancy word for saying deduced, what can be figured out but not directly given, we're going to use a geometric principle for that. And you're eventually going to get to the point where you get a final proof and what the reason is for that. Okay, so again, you don't have to take these notes here, but I want you to understand basically the process, because when you go to the next page, now we're going to actually look at an example. Okay, so complete the two proof column. What we're trying to prove, first you might want to start with, well, what is the point? What are we trying to prove here? We're trying to prove that this angle M, right, is congruent to angle D. So let me mark it first. Well, I'm not going to mark it because I don't want you to assume that. I'll explain the marking in a bit. Okay, so again, we're trying to prove that M and D angles, they're the angles. Well, what's angle M? It's this one, right? But again, I'm not going to leave it marked because I want to get proof that I get there. So I'm going to take it away, but I just want you to show that that's what you're trying to prove, okay? Well, they start by giving us information that, right off the bat. The key thing is we need to make sure we mark up our diagram. Now we can use that to mark up our diagram, and also we're going to be putting it in here. So let's just take one. We know any of these we can use to start off with. So they're saying MN, so I'm going to use this one right here. So you would write that given statement, MN. And the reason I'm writing one of these up here, the given ones, is because I see that the reason that I'm going to have is going to end up being given. As a matter of fact, let me check this out. I want to make sure I'm not, okay, so there's two, they've already given a statement. So what we're going to do when you take this quiz or the test, we're going to give you a partially filled out diagram, and you're going to figure out from what you have what would make sense. And the reason I'm saying that is because if you look at number 2, it says NO, segment NMO is congruent to EF. Well, that's right there, right? So that's also going to be given. But if I would have put it right here, then I would have like repeated. So number 2 is given, right? Because it comes from the list right here, right? So we already got that. But I'm going to take this one, which is not anywhere in these statements, and I'm going to go ahead and put it in. My writing's a little bit sloppy. I apologize. So we get DE. Again, I got it right here. It's in the given list, so it's given, okay? Number 3 is something else is given. Well, there's only one thing left, right? So OM FD. Okay, good. So now the next thing, we actually have a reason. Oh, by the way, I should be marking these up. Okay, you also want to be marking these up. So MNDE, right? MN is this one. DE is this one. NO is this one. I'm going to use 2 lines for that one. EF is this one. OM, well, they're giving us everything, aren't they? OM is congruent to FD, so mark all that. Now, you should know at this point that if you've got three sides, corresponding sides, this side's got 1 dash, 2 dash, 2 dash, 3 dash, 3 dash. We should know at this point that that means those triangles are automatically congruent based upon, and they're giving us the reason, they're giving us the principle, side, side, side. So what is the statement that we would make based upon the fact that we have three sides? We're basically saying that triangle, oh, we need to put it in the right order, right? So M to N is 1 slash. So M, N is going to be match, and then I'll make that O, right? But the first two letters are, that's not very good M, is it? Sorry, writing on the computer screen for me is really hard to make it even neat. So MN is the first two letters, and that matches the one with 1 dash. So, but I got to go in the right order. So I go from, okay, so is it DE or is it ED? Okay, well, let me try ED first and see if that works out. Because in the last letter would have to be F, right? Now let me make sure it's in order, because here N and O has the 2 dashes. So F and E have to have 2 dashes. So N and O and F and E need to be in the same spot. N and O and F and D, or F and E, sorry. Oh, so it's not. So what that tells me is the order is mixed up. I need to make these two, hold on. So I need to make those, I need to swap the E and the D. It should be DEF. So let me go ahead and erase that. So that's a good practice for knowing what order things need to go in. So I'm going to go like that. Oops. So it should be D, E, F. I'm going to try one more time to confirm it. M and O is, or M and N, sorry. MN is 1 slash. So that means DE, the first two letters should be 1 slash. Ooh. Yeah, they are. Sorry. Brain freeze. Okay, so they are. Okay, NO, the second and the third are 2 dashes. So the second and third EF need to be 2 dashes. Good, so we're good to go. Okay, good practice. Now, we're not done, because we weren't trying to prove that the two triangles are congruent, but we know this. If that two triangles are congruent, then all their angles are congruent. If they're congruent because of all their sides, that means all the angles are automatically congruent as well. So how do we know that angle M is congruent to angle D? Well, it's in between 1 and 3, right? M is in between 1 and 3. Is D? Yes, that's between sides 1 and 3. So that means it's congruent. But there's a concept called, where'd it go? I talked about it, I think, briefly before, but now this is really important for you to get it. Corresponding parts of corresponding triangles are congruent. CPCT, and it is also listed right here. So maybe put this in your notes on the next page. Corresponding parts, the next P is parts, of corresponding, I'm going to abbreviate that, triangles are the last, so that was the T, the triangles, are congruent. Simply, this means if the whole, if both triangles together, the whole are congruent, then each of the individual parts are congruent, including the angles. So that's kind of a new concept. So please make sure you take that in your notes and then write it down here. Okay, good. So basically, that is how these proofs are going to work. Again, summary. You're given some figures that are not marked up. You're given specific information saying you're given that. And then so you take that given information, mark up the diagrams, and put the information in the chart. And then the other stuff is thinking about what you're trying to prove, and then what other things you need to prove that that they're equal. Okay, and then that would be where you give reasons for them. Okay, so now it's really important. We only had one reason, really. Well, we had two that were not given. We had the SSS congruence, and we had the CP-CTC. So here is a list. So this is going to be something you'll want to refer to when you are doing proofs. Here's all the different reasons to state that angles are congruent. And so you want to take a moment to look over this. Vertical angles, you know about that, right? X and Y. See if I can make this better. Reflexive property. Okay, that was like this, right? If the two things are next to each other, then this one right here is going to be reflexive. Perpendicular lines. Okay, so right angles are congruent. If you got one that's 90, then you know that that's 90. So you would list this as your reason. See, these are the things you would put down in that flow chart, right? You'd put this, you'd write that in there, you'd write that in there, and that would be the reasons, right? That's how you do this. Okay, alternate interior, right? So if you got something like that, you know, these are parallel, alternate interior, etc. I won't do all of them because you've done it before. So you may want to make little drawings to the side to jog your memory. If given an angle bisector, so if you've got this angle here and it says that this line is bisecting the whole angle, then that means that these two half angles are equal. And if you've already proven congruent triangles, then that's where this comes through. Again, we wrote it down earlier. Okay, those are for angles. The next thing is sides. Okay, if you're given a midpoint, right, they say that ABC and that, all right, let's make that C. If they're saying that C is a midpoint, that automatically means those two are equal, and you would put down midpoint definition in your reason list in the column. Same with the segment, bisector, reflexive property. Again, I think I actually gave that as the example for the angles, but this is for that's for the side, basically. The share side, so that means this one's congruent. That's pretty much it. And then other reasons to state the triangles are congruent. You've been doing this already. Those ones right there. So when we take a quiz on this stuff, this is probably the notes that you're going to really want to refer to prove that things are congruent. Okay, so for your homework, you're going to basically be doing, oops, not homework, but your assignment. Homework if you don't finish it. So again, for your assignment, you'll be doing pages 16 through 18. And when you're done, make sure to show it to me and I'll give you credit for that assignment, okay? All right, thank you very much for listening.